Okay, so as I was saying, I gotta talk. Okay, that's when I'm nervous. I just start talking. All right, so we're gonna talk about probability today, and I'm just gonna do my best. I got a little script here. I decided gonna make sure I follow it. Got this game plan down real tight today. We're gonna talk about the addition rule of probability. Also, it's kind of the thing that happens when you have an or statement, when you say this or that has to be true. So, let's just get right to it, and let's see if we can get this done in between the guy with the chainsaw outside cutting a tree down. All right, here we go. So this is the stats from the Titanic. This is the actual stats of the passengers. Okay, so we've got the class that they were in, whether they were at first class, second class, or third class, and then this variable of whether they survived or didn't survive. All right, well, let's look at our first question. What is the probability that a randomly selected passenger would be in first class or third class? So right away, you have to realize that in this case, these two events are mutually exclusive. So I'll write that somewhere here. Let's write it right here. So what that means is that you cannot be both. You can't be both in first class and also be in third class. You got to be in one or the other. There's no overlap in that Venn diagram. And when that happens, the rule for addition is all you got to do is add the probability of first class to the probability of third class. And you're done. So let's do it. So it's going to be equal to the... Beautiful. Okay, so we got to add the two together. So let's see, what is it? Let's go with the probability of first class. So first class, we have 324 total people in first class. Over the whole boat is 1,317 passengers. So this probability of first class, let's see here, let's go. I'm going to get set up, is going to be 324. Now, probability is the number of desired outcomes over all possible outcomes, assuming all those outcomes are equally probable. We're going to put the total possible as 1,317. Okay, so that's the probability of first class. Third class, we have 709 desirable outcomes over 1,317. So if you add them together, let's see what it is.
324 plus 709 is 1033.
Or 1,033 over 1,317. So that's done, but fractions are a bit harder to compare than decimals and percents. So I'm gonna make this a decimal here. U17. And we get 0.784. Okay, approximately. Okay, so it's 78.4% likely that a randomly selected person from the Titanic, or passenger, will be in either first or third class. Now, when you have a table, you can also just add it up. You could say, okay, well, it's 324, and there's 709 people here. That means in total, there must be 1,033 people who fit the condition of either first or third. Beautiful. So that brings us a rule. And a rule is if you have two events, I want to leave the camera there. Let me switch to a different color so hopefully it stands out a little bit. Let's go to green. Is that the probability of A or B is equal to the probability of A plus the probability of B. So that's any two events, A and B, assuming the events are mutually exclusive. Now, let's see what happens if they are not mutually exclusive. Okay, well, let's keep this train going. Probability of first class. So what's the probability of a randomly selected passenger that they'd be in first class or that they would have survived? So let's do a Venn diagram first, kind of see what this might look like. So we'll draw this here. Let's put a circle that represents first class. And now let's do a circle that represents survived. And you see there's overlap. Because these two events are not mutually exclusive, which means you could be both. You could be in... Oh, come on, draw my marker again. Okay, you could be in first class and also survive. And so this overlap is going to change our rule. So these are not mutually exclusive. Okay, so what do you do in this instance? Well, what you do is you're going to take the probability of first class. Okay, probability of first. Now that's all of this. That's going to be the whole, everybody who's represented by first class. And you're going to add it to the probability of third class. Of survived. But you can see the issue here is that, look at, there's overlap. So what you've done now is you've actually overcounted the middle part. And the middle part is actually where both first and survived is true. Like every dot in here is inside the red circle and the purple circle. And so what you have to do is you have to subtract the probability, and I'm going to use first and survived. I.e., you've got to subtract out the overlap. You've got to subtract out that part. And it really makes sense too, because if you go up here and you say, okay, first class, how many people survived? Or how many people were in first class? There's 324. And then you say, well, how did you get that number? Well, you go 201 plus 123 gives you 324. Oh, okay, so let's do that. This will be the probability of first class. We'll go 324 over 1,317. Beautiful. Okay, you sticking with me? Okay, now let's do the probability that people survived. Okay, well, we got to ask ourselves, how many survivors are there? Well, let's look. Oh, there's 500. And where did that number come from? Well, it was 201, the first class, plus the second class, plus the third class. And you can see, look what happened. We double counted these 201 people. The 201 people we already counted for first class, they also survived. And you can't double count them because now you don't have that many people. You don't have 824 people who either were first class or survived, not different people, because of these 200 that you've double counted. And so what we got to do is this. So then you say, okay, so we have the 500 over 1317, or 1,317. That's the probability of survived. Then you've got to subtract the double. You got to subtract the 201 people who were both. Yes, who were both. Well, 1,317. So what does that give us? Well, let's see. We got 324 people plus 500. Let's subtract the overlap, the people who are both, and you get 623. 623 over 1,317. So let's divide that, and you get approximately 47.3% or 0.473. So this gives us what's called the general rule of addition, which is here. And this is for any event A and B. They don't have to be mutually exclusive. These ones have to be mutually exclusive. For any event A and B, the probability of A or B is going to be the probability of event A plus the probability of event B minus the probability of both A and B happening together. Now you could always use this definition because when things are mutually exclusive, the probability of A and B is 0. Yeah, it's 0. Beautiful, right? Okay, so this is the introduction to the addition rule. The probability of two events, you add them together. Because if you think about it, every time you use the word or, you're increasing the number of desirable outcomes. And so the probability should be going up. It's like with me, if you say, what's the probability Mr. Miller's going to drop a marker? Or use this calculator. Oh, it's going to go up a lot. Or use this blue marker, right? I mean, every time you use the word or, probability goes up. Okay. I think for now, we're doing very beautiful. I hope you are too. Take much care, and I'll see you around.